Recording in progress.
Okay, so number systems, right? I'm going to use this game that I throw online to just show a little bit like how these things are done. To me, I think it is an easier way to. But the thing is that you do need to remember, right? Are these conversion tables or these simple number conversions like binary to decimal, 0, 1, 2, 3, and then 4, 8, 16, these numbers, right? You need to remember these so you can do things a little faster. And then for octal, it's basically the 7 numbers, right? From 0 to 7. How do you convert that between that and the binary? And hexadecimal, it's 16 numbers, right? From 0 to F, right? 0, 1, 2, 3, 4.
So should we solve this?
To 9. I'm just going to show you one, right? So for this one, this side is octal, right? 1374 is octal. So if we want to convert that into hex, what we do is, what I do in here is to convert that into binary, right? So 1 is 001, and 3 is 011, right? And 7 is 111, and 4 is 100. Right? So these things you do need to remember. And now what do we do? Now I'll just convert every 4 bits to hex. Right? So 1100 is what?
12.
That's C, right?
Yeah.
Okay, and the next is 1111, which is easy, right? F.
Yeah.
Right? Hi, Melody. Right? That's the last one in the hex number digits, right?
So it's 2FC.
So that's F, right? And now what we have left is 0010. It's 2, right?
2FC.
Yeah. So in this game, if you did it right, it'll tell you. Okay. So so I mean, if you got a computer, I mean, you can try it at home. And every time you can, if you want a new set of games, you can just click here.
Reset this game.
Yeah, you can reset the whole game. And I put a timer here just to tell, how many. Yeah, because I let it running on my screen there.
We like, so like for the final day, are we practicing each of these? Like,
you can practice this just to make your mind works, faster with these numbers, right? And also I want to, well, I'll probably do some more, add some more stuff in here, because right now it's just, I'm just throwing it up there as a proof of concept to see if that these things help, right? So there's that, the conversions, right? And the other thing that the most difficult part in this one is probably, if you have a few different numbers in different, you have an octal and a hex and a decimal number, and then you need to do like multiplication, right? In those cases, it's probably easier to, convert the numbers into decimal, because that's what we are mostly familiar with, right? And that's, I mean, what you spend most of your time at school learning. So you convert that into decimal, and then you do your math, right? And then if you need to convert it back into like hex, do that. So there is conversion between let's say like decimal with decimal. If you want to convert that, right, it's easier to do the additions, right? So let's say if you have a number that's 345, right? That's decimal. What you do is you use the numbers that are in here that are what's the word? The power, the power of twos, right? So this would be, 256 plus something, right? It would be because it's bigger than 256, right? This number. And what do we have? I guess because the double of 256 would be 512, right? 512 is bigger than 345, right? So this number, when we break it down, it's going to be like start with 256. Okay, plus 64, right? And then plus something, right? Good. Did you do all that, or did you?
Wait, it's not even a like. Oh wait, it's an odd number.
Okay, so this is exactly how you would break it down, right? 256 plus 64. That is what is that? That's 320, right? 300 320, right? 320 320, and now what you have 320, you have 25 left, right? 25 is 16 plus 9, and 9, which is, then we break it down, which is 8 plus 1, right? So you break that number down into this. So what this means is that now you have 256 is actually 1 0 0 0 0 0 0 0 0, right? In binary.
Wait, that's binary?
Yeah, that is binary, right? And so, sorry, what?
Is it because you add the 2 plus 2?
Let me check. So yeah, the number of zeros you put in there is, it might be a little hard to start with, right? But what you do is you remember these things by remembering the little ones first, right? So when you do, 0 is 0, right? 0 in decimal is 0 in binary, and 1 in decimal is 1 in binary, right? Those two numbers equal to each other. But then 2, right? When you have 2, right? 10 in decimal, then it would be 1 0 in binary, right? Because, well, 2 is 2 to the power of 1, right? Right. 2 to the power of 1 is 2, right? And then the next one is 4, right? The double of 2 is 4. So what you have is a conversion table like this, right? So 0 is 0, or let's say 0 is 0, 1 is 1, right? And then 1 0, or no, 2 is 1 0, right? And then 4 is 1 0 0.
And then it goes
Right.
on.
Yeah, exactly. So every time you double in binary, you shift,
No, you
the
add
number
1 0.
becomes the one longer, right?
1
You
0.
add a 0. And now the next one is 8, right? Then it's what, 1 3 zeros, right? And the next one is 16, right? That is one more 0, right? 1, right? So this is how you remember these numbers. It take a little while to, to get to probably 256, but it's not going to take that long actually, right? If we try it, the next one is 32, right? 32 is 1, and so you got 5 zeros there. Now you got 4 zeros there. Now you got 5, right? So the next one is 64. And that is going to be 1 and 6 zeros, right? Yeah, exactly. And so, yeah, but you break that down, right? If you do have 1 1 1 1 1 in binary, that's 1 with all zeros plus the next one with 1 less 0, right? So binary, let's say 1 1 1 1, right? What is this?
8 plus
That's 15.
4.
That's 15.
Right?
That's 15.
Yeah, exactly.
Yeah, it's 50.
Now the next time you look at this, you would remember. You would just, it just automatically comes up, and it's F in 16. Right. So, I mean, it might take a little while for you to, get these numbers down, but it shouldn't take really that long, right? That's what that's what I can, give you guys. Okay, so we can try to, do a test here, right? Or just pick a problem in here. See if we can.
Wait, what if we did like the stuff in the game? Like,
No, we can do that too, also, right? So this might be a little easier. Let's pick this one. Yeah, we probably did.
No, I don't.
So let's do this one, right? So 1 2 2 4 in hex, right? That would be 0 0 0 1, right? That's 1.
0
0 0 1 0.
It's
0 0 0 1
Right. This side is hex.
0 0 1 and
0 0 1 0 again, and 0 1 0 0, right?
now you want to split it into like 3 digits.
Hello? Hey.
哎，王老师，
啊，
你今天还有一门课没上完呢。
对啊，我在上吗？
哦，这上了，那就行了。刚才有家长催我，是说他们找不着你，那就行，我挂了。
没有，我在这儿呢，我们一直在这儿，我们已经开始了。呀，
哎，那个录入上面老师，那个有孩子看不到，怎么回事啊？
有啊，他在这儿。
那行吧，那行了，好嘞。
Okay. Melody, are you? Are you?
The answer will. Yeah, I can hear.
Okay. You can see the screen too, right?
Yeah.
Okay.
Yeah.
No, because you convert it into octal.
Right. So this is the whole binary, right? We turned that hex number into binary. Now we just, the way I do it is I mark every 3 bits, right? Because we're going to turn it into octal here. So I mark every 3 bits. So 100 is.
I converted it. What? All of us converted well. Oh yeah, we all convert.
Okay. This is 4, right? So the next 3 bits is 4 again. And the next 3 bits is 0. And the next 3
Next is
bits
1.
is 1. And the next 3 bits, well, yeah, 1 again.
And the
We'll
last
just,
one is just 0.
yeah, we'll just remove that. So that's
Wait,
it.
why did you remove it?
We don't need the leading 0, right? It's okay to leave it there, but we can remove it as well. Right, so it's 11044.
If you put the extra
In-
0, you still marks wrong.
Wait,
Nope.
no, did you
It's
do
still
like?
right. Right, the leading 0 is
Yeah, that's right.
okay. Right, like you in all math, the leading zeros are ignored, right? Basically.
Next.
We can do this one.
That's
So-
0, 1, 0, 0, and then
1
F is
1
just
1 1, right?
and then 6 is 0, 1, 1, 0.
Exactly. Okay.
And
So now we do this, right? Mark, take every 3 bit. So 110 is 6, right?
wait, 0, 1, 0. I'm doing it.
And 110 is 6 again.
The answer should be 2, 3, 6, 6.
Ow.
Yep. Yep, you're right. Right, so 2366. Right. And
Yes.
let's do this one. This one is
Okay, so it's 7 2. Okay, so it's octal.
so that's
1 1
1 1 1
and then 0 1 0
0 1 0
0 0
0 0 1 0 1 1. Yeah. Oh, sorry. 0 1 1.
All right, so
Okay. So every 4 digits, right?
every 4 digits.
Remember what that is? 1 1 0 1 1
1 0 1
8
that's B.
plus.
is B, right?
Wait, hold on. I'm figuring out.
Okay. And 1 0 0 0
1 0 0.
10 is A, right?
That's 8.
is 8.
And the last one is what is it?
So it's A plus 4 plus
E.
E. Yeah.
A plus 4 plus 2. So
E8.
E8 B.
14.
Right.
14 is
And just, I mean, if you want to, you can go home and play with this and just to
E8.
get your mind into this game, right?
What's the website? I can't quite see it.
Oh, it's
It says-
ACSL dot
Studies.
study-in.us.
And then
Dash.
No,
US.
slash games.
Well,
Dot US.
if you
No, you
just
just search that. You don't need the slash.
ACSL dot study dash in IN.
In dot us.
Dot
And then I'm gonna
US.
write the slash games just in case.
So yeah, so that's the number system stuff, right? Let's continue to the next one, which is expression notation.
That's pretty easy. That's what you want.
Okay.
Expression notation. Okay,
Is
yeah.
that easy?
It's
not?
Wait.
Okay.
It might be complicated for like some stuff like
The things you need to remember, what you guys learn at school, right? What is that? That's infix, right? So with infix expressions, oh, that's Boolean algebra, right? So in the expression notation stuff, it's basically the addition, subtraction, all that, and parentheses, right? That's what you're talking about. That's the elementary school level math, right? And the infix notation is basically what you learn at school, right? A plus B, like I have two expressions here, right? A plus B divided by C. Because with infix, you have to watch the precedence rules, right? That's why I'm listing that I put that here as a key point. That's the key point with infix expressions, right? So with a plus b divided by c, you have to do b divided by c first, right? That's what you learn at school, right? And then you have parentheses. So if you have a plus b in parentheses and then times c,
Okay, no, so basically infix is
It's operation and operates.
Yeah.
And then post and prefix is like normal.
right,
Prefix is basically school. It's basically normal.
right. Infix is just the normal
And then
math.
postfix is operators and operators.
Prefix is the operator first, right? Operator and then whatever you need to operate on. So if we turn that a plus b divided by c into prefix notation, then we have to put that division before b and c, right? Because that's when the computer handles this prefix expression, it will look at what it has, right? Currently, like when it does that from the beginning here, right? In this expression, first it look at the plus operator, right? Or addition, right? And then it has an A. But then the next part, it does not have an operand, right? It has an operator, which is the division. So it'll have to put the other part aside for now, right? And do that first, right? Because it always have to have an operator followed by two operands to do that operation, right? So it will do b divided by c first, right? That would give you the result as exactly as the infix expression up here, right? Which is a plus b divided by c. So you do the b divided by c first, and then add that result onto a, right? To get the whole result. And in the second expression, right,
you do plus AB first, and
Right.
then times the sum of AB and then C.
exactly. So with that, you can see that we have this operator plus, right? The addition operator that followed by A and B, right? So we do that first. And then once we got that result, right, then we have an operand here, which is preceded by the multiplication operator and then the C operand. Then you can finish that, right? Well, now we got more people here. Sorry for the guys who came on late. Just to let you know that we are we're reviewing the topics for the elementary division, right? These are the four topics that we're going to encounter in the competition, which is, first thing is the computer number system. So let me copy this URL here. So that I put a couple of simple games online that only, actually only has something to for this part, for the number system part. I don't have anything else yet. So that's the URL. And then the second topic is the prefix, infix, and postfix notation of math expressions. Okay. So okay, we're now to postfix, right? So for postfix, you're going to have operands followed by operator, right? So in here now, let's see, B divided by C is done first, right? So we put that division operator right after B and C, right? So when you process this expression A, B, C, then you see a divide, right? So you can work on B divided by C. Right? Once you get that result, now you have A in that result and then plus, right? Then you can finish that operation right there. So all these three expressions are equivalent, right? They equal each other. And then the other one also are equivalent to each other. So this part, what you will need to do is really, one is to deal with these kind of conversions, right? So you're given an expression, you convert it to something else, right? So for example, if you are given a postfix expression like this one, right? AB plus C times, right? If you're given that and you're asked to convert that into infix expression, for example, then you'll see this AB plus, right? So you're gonna have to do that first, right? To guarantee that it's done first, you can always just put it inside of parentheses, right? So it becomes A plus B parentheses, right? And then you can also, parentheses this whole thing, right? So it becomes left parent, A plus B, right parent times C, right parent. And that is exactly the same as this one, right? And then you can get rid of the pair of parentheses on the outset, right? So that's how, you can convert between these different notations. That's one thing you will encounter in these problems, and the other one is to find the solution, obviously, right? So you're given a bunch of numbers, and where you can actually perform these operations, right? Oh, yeah, you're right. We in our in the problems that we demonstrated in class, we did have those like pound and exclamation mark as operators, right? Those are just different operators, and they're not normally, I shouldn't say that, they're not often, right, show up in your learning at school. So in those cases, they will be explained in the problem, right? It'll be defined actually in the problem. They'll tell you exactly what that operator does. Okay, and so don't worry too much about what operators that might show up in there, because they will tell you if it's outside of the normal, the common. They very often seen ones, right? Plus, minus, or addition, subtraction, multiplication, and division. Right. Outside of these, they will normally just tell you what you're seeing exactly. Right. So in this case, let's pick a problem set and see if we can work one. Right. So this is the kind of problem sheet you will have, right? You'll have 5 problems, and you have, I think, 30 minutes to finish this. So the first one is a prefix expression. Okay, want to try to solve this one?
Is it 24?
I don't know. So that's very good. That's very quick. So, and we can try to do that. Let me copy this over.
-2 times 5.
So what I'll do is I'll copy it down here, right? And I'll let you guys finish this, and then we work on this together. Remember, this is prefix, right?
Yeah. Times
The answer for number 2, 5.
I don't know. Again, that's a good
So
question.
wait, what? So prefix is you do
Prefix to
times 5. Postfix is 5 to. Yeah, that okay. So. Yeah, okay. Well, 5 times 3 is 15. And divided by plus, and then 6 divided by 2 is 3. And then 7 times 3 is 21. So then I need minus 15 divided by, so plus 3 to 21, I mean, is.
That's, well, if you guys want to just continue, finish all this, that would be good. You can do that, and then we come back and finish all of them together.
Yeah, same.
I think I somehow messed up. I'm going to redo it.
I got 3. Okay, so now we do postfix, the postfix expression. Wait, teacher, do we do the postfix after we're done with the prefix? Okay.
We can do. Do you need some paper? Or somebody left this notepad here. You can use it. Okay.
So then 2 power 7 3 plus 6 4 minus times plus 3 to power divided. Okay. 5 to the power of 2, wait, 5 to the power of 2 is 25. 7 plus 3 is 10. 6 minus 4 is 2. So 3 to the power, okay, so times 5 to the power of 2. That's 25. So then 3 to the power of 2 is 6. And all right, so 25. So 10 times 2 is 20. And plus 6 divided by, which equals 25 plus 20.
I got negative 3.
Cool.
What was that what you got?
Hold on. Wait, what's, I don't,
What?
did I do something wrong? Because you can't do,
Whoa.
shoot. I don't think you can divide 45 with 6.
Is this wait, you got 5. How did you get 6?
Hold on.
Wait, look. Okay,
Hold.
this is not a multiplication sign. This is a power sign. So this should be a 9.
Oh, this is not, oh my freaking god.
So then it should be 40 times 9.
Wait, this is wrong.
What
This
should
is
change
wrong. And then final day. Day
5 times 8. I'm supposed to do 25 times 8.
5 2 to the power 7 3 plus
Then fix the
6
post 6.
4 minus, hold on.
25 times 8 is not too bad.
Times
And
plus
25 times 4 is what?
25 times 400.
okay, I'm reading.
That's 100, right? And then you time 2, that's 200.
6 6 minus 4 is 2. And
Is
then
it postfix?
times plus, and then 3 to the power 2 is 9.
How am I supposed to do 200?
So
91.
10 times 2 is 25, and then 20, and then plus, and then 9 divided by equals 45, 9 divided by. So that means it's 5. Yeah, okay, I got 5. I just solved it. So now we do question 3.
I literally just skipped like 2
Translate the following infix expression. Oh my god.
Yeah, I already did that one. That's still good.
Okay, I'm going to have to use my big brain. Big brain. So it's to postfix, so I'm gonna have to do. Hold on. So 7 goes all the way in the back. 9, 1 plus. Wait, hold on. You're new. So 1, 2, power.
So division first, right?
What?
Division first.
Jesus
Okay.
Christ. Holy crap. Holy crap. Holy crap. Holy crap. Holy crap. Holy crap.
I want the last problem.
crap.
I want the last problem.
I'm going to go crazy
Why are you going to go crazy? There's no reason
because Among Us is not.
to. Because of Among Us. Bro, you know that game died like 2 years ago.
I mean, people are still playing it.
I know, but it's still dead.
Did I get it right? Wait, did I get it?
Is
Is that what you got?
Is number 3791 plus?
No, because you gotta turn it into
opening
postfix.
See, this is post.
63.
Did you use number 3?
Closing
Yeah,
parentheses, minus
this is
power of-
post.
This is what I got.
Okay, you guys done?
We have to. Bro! Wait,
What the heck?
3 to the power of 7 minus 5. Wait, so then 3 to the power of 7 minus 5 equals 3 to the power of 7 divided by 3 to the power of 5.
What's 2 plus 6?
2 plus 6 over.
That's 2.
That's 2.
That's 2. Whoa, 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 whoa,
If you
whoa,
can't
whoa.
calculate that, you're probably mentally ill.
No,
The
you're not.
top number minus the bottom.
Times 8 divided by.
Okay, so plus 9.
3 to the power of 7 divided by. Did you know that 3 to the power of 7 minus 5 is 3 to the power of 7 divided by 3 to the power of 5?
Yeah, of course.
Boy, your new brother is Ball Boy. What are you doing?
What the hell?
What the hell you say?
It's okay. All the positions at once.
Calculate the problem.
This is
Calculate the
calculus.
problem. Calculate the problem. Okay.
This is calculate this.
How
No.
are we supposed to
You go to
do
middle
this?
school.
Yeah, I go to middle school.
You know how to bypass security?
No,
I guess.
no.
Just go into Google, type in calculus tips.xyz, and then you can type in anything you want, and it'll block you.
Bro.
You know,
2,
bro, but
6
still, it's very useful.
plus 6. No, 2, 6
I'm literally
plus.
trying to make a list of like
You
calculus.
seriously think I'm gonna be
You're
able
trying to make
to?
a proxy. Wow. Motion damage.
You
Oh,
just
sure,
skip number
man.
4 because it's so confusing
I got it. I already did it.
and
So-
I don't realize what
4 too much. I am literally, my brain is malfunctioning.
Now, function. Human malfunction. 10.
8, 4, 2 minus.
Whoa, whoa, whoa.
Whoa, 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 whoa. Whoa. Oh my god. Oh my god.
Oh my god. Oh,
That, okay. Oh my god.
Right, the first one is this, right? Is this how you guys did it? 3, right?
Hold on, I am trying to put my brain in this. 5, 2, yeah, it's 3, yeah.
Right.
2 equals I screwed up badly.
I
So
think I
the
saw
underlined parts are what I did in each of those steps, right?
Isn't it supposed to be negative? Make it negative 15 plus 8.
No, it's 15 minus 15
Yeah,
subtract, right? 12.
number 5 is just.
Well, it's not.
I just had to solve number 5. And then
I feel like number 4 is the most torture.
But I feel that.
We all have different.
Okay. So
9 plus 3.
Okay, 12.
I'll do that, right? Each part, that's 5 to the power of 2, that's 25. So
7
this
times 4 plus 5.
7 plus 3 is 10. Okay. 6 minus 4 is 2, right? And then here, 3 to the power of 2 is 9, right?
I am crazy.
So now the next part we can do is this, right? This part, right? That 2
I
times
translated it
2
into,
times 10 is what, 20, right? And the next part we can do is this. That would be what,
okay, time to do actual
45.
torture.
right? And 9 divide. So that gives us what, is that what you have? 5 for number 2?
Yeah.
Yeah, I solved all 5 problems. I solved all 5 problems. You get 5.
Yeah. This number 2, right? You get 5?
I screwed.
Okay.
I didn't
So,
screw myself up.
like what I do here, just underline what you're working on each step, right? So in first, this is the question to begin with. Okay. Well,
Yeah, I need.
in one step.
absolutely no.
Well, you probably can.
It took me 1 step. Like 3 and 4.
Okay.
Can I go to the bathroom?
Yes, you
Yeah, go
can.
ahead.
Now go. My child.
Is this the vanishing to get in
No.
Right. What do you do is, like I say, underline what you are working on each step. Okay. And then you just copy the rest down.
Bum bum bum. Boom, 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 boom,
so
boom,
that you don't miss it.
I mean, I missed an addition symbol when I was looking at the end. When I wrote the division symbol, I thought it looked like one.
Lobster!
Okay,
You're gonna see what happens when you miss the move.
so this is infix to prefix,
You guys.
postfix, I'm sorry. So what we do with this is that we can copy all the operands down,
Done.
right?
I think I'm done. I don't know.
We copy them down and then what we do is
I just finished all
number
my-
3.
Yeah, this is what I
So-
did. I just put some unnecessary parentheses.
Untable.
So what we do here now is we just we're just going to do the ones that needs to be done first, right?
Oh, the microphone is plugged into here.
Right. So and then we consider the rest, right? So once we get those parts done, right, then these don't matter that much, right? So we can just do it here. And also, we have to get this part done and then do the addition, right? We can do that addition here, or we can do that addition
We can watch him.
then here, right? We can do it either way. We can do it here, right? And then we got to finish all these, right? Before we can do that multiplication, right? So we got to do all that and then do the multiplication, right? So this is how we got that into postfix, right? And now if you look at this is postfix, right? The only thing you can do now is this part, right? This is what you do first, right? Right, and then you can do this, right? Or you can do, you know, so basically you got this part done, and then what you have left is the 7 times whatever that is, right?
Oh, wait, hold on.
I just realized why
Whoa, 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 whoa.
I did
whoa.
addition before anything else. Because it was like 9 plus 1, so I did 9 1 plus.
Wait, so that's the equation?
Yeah, that's the postfix, right, equation.
I mean, I got part of it right, but like some of it I got wrong. I got 1,
So
2.
what you do is you just copy all the operands down, right? Right,
You take
like
that and you-
all those numbers, like 7, 9, 1, 2, 6, 3. Just leave them as they are in position,
Oh.
and then you take the operators that you have to do first, like this power, right? 1 to the power of 2. So you got to do that first, and you just take that operator and put it right after the operand, right? Right. Let's stop playing. Let's finish this, okay?
So you just like copy it and then like
You copy the
Organize
operands
it.
down, right? And then take a look to see what you need to do first. You need to do the power first, right?
I didn't.
and
So you take that power operator right there.
I didn't.
And then you do the division, right?
Yeah, I just.
And then you put the division right there, right? And after that, you can do this or you can do that. Either way, right?
So you like do.
So let's say we do this, right? 9 plus this. So we take the plus, the addition, and put it after 9 and this thing,
Okay.
right?
Okay.
Right? And then we do the
Minus.
subtraction, right?
So you put it
We
in
take that
the.
subtraction and put it after this, right? Post.
So then you're done with the parentheses.
Right.
Now it's the.
So
it's just the
you're done with all the parentheses stuff. So you just take that multiplication and put it after everything,
That's the same
Okay,
thing.
and you're done.
I think I
And
know
then,
what the.
and then you do the same thing. So you have to like go in the next one. You just have to like put parentheses.
We're good?
around it. And then
Okay,
you-
so if you are doing prefix, then you're just putting the same sequence. You're just putting the operators. Yeah.
I literally like understand how to do it. I just got them in the wrong order because like I forgot you
Okay.
need to do addition first and then.
Let me do add some line.
Oh my God.
It's been like a few seconds. Oh, like
What
a
middle school do you
few.
go to?
A few
Um,
seconds is way longer than a few hours.
Like, what middle school do you go to?
Okay, let's
I don't know.
take a 5-minute break, and then we'll be we're back in doing this, and also we got 2 more sections to go over. All right.
Can we try the microphone thing?
Okay, so this is that expression, and it's infix, right? So what we do now is, again, we copy this whole thing down, right? So we will need to remove the parentheses, right? So, for example, this, right? We'll take the minus subtraction. What are we doing here? Number 4 is to postfix, right? So postfix is we put that out here, right? So we can take that out, right? And now we do this, we do the power, right? The power is basically those, let me start using a different font so that it's easier to read, right? So now we do this, right? And the next thing is we do these, right? We can do this, right? This subtraction, we can do that, right? And once we did the subtraction, we can do this multiplication, right? The multiplication is multiplying that expression, oops, that expression, right? This expression and this whole expression, right? So we put that multiplication sign after this, right? We put that multiplication after this. So this part is done, right? And then we can do this, right? There's a parentheses here. We remove that. We will do the addition first, right? And now we can do this, right? That's this part, right? That's this part, right? Now we're done with that. And now what's left is this, right? oh, let's see. Yeah, we can do that. We can do that. We can do the multiplication first, or I mean, if we want to follow the stuff exactly, we can do that. Can do that. There's a, no, hold on. I put this in the wrong place. Because this subtraction is already there, right? Can do that. And this is done after this, right? So what you can see here is this 4 subtract by 2, 4 minus 2 is done first, right? As shown in this expression in problem number 4. And that 2 plus 6 is also done first, right? Right? Because you got that 2 plus 6 there, and then divide by 4, right? And then that part is also done, right? And then you do the multiplication, right? And then this part is also done, right? That's 3 to the power of 7 minus 5, right? And then you do that multiplication in the end. So basically what we did here is copy down all the operands, right? All the operands, and then you put the operator after the 2 operands that you need to work on right away, right? So that's it. And the next part is the Boolean algebra. Boolean algebra is a little bit complex, right? As you guys probably you said earlier at the beginning of this class. But really what you have is the set of laws of Boolean algebra, the set of rules, right? Well, to begin with, we have these operators, right? Not, and, or, XOR, XNOR, right? The last two, you can actually sort of, they're less important, as I want to say, because they can be expressed as other operators, right? Like XOR can basically be expressed like that, right? Because it says it can be either, XOR basically says X, XOR Y, right? This expression is equivalent of this, right? It's either one could be true, but not both, right? If both are true, then it means false. The end result is false. So if you look at this expression, so if either one of X, Y is true, then this part is true, right? And then the end part means if both X, Y are true, then a not, right? Not means you can't have both be true, right? If both are true, then this part is false, right? So as you can say, this XOR can be expressed as the first three, right? So the first three is already complete, meaning that all other Boolean operators can be written as those three, right? Those three are not, and, or. Okay, these are complete operators for Boolean algebra. So as long as you understand all the rules surrounding and, or, not, right? These three operators, you should be good to go. And now comes the laws right? The laws are, commutative. Commutative means that things could switch around, right? They can commute their spots, right? X and Y is equals to Y and X, right? So if you switch Y and X around, the result does not change. That's what it means. X or Y, the same, right? That's commutative. Just, remember the meaning of those. That means, they can switch positions, right? If it's and or these operators, they can switch spots. Associative means that if you have a series can change and the result does not change, right? And idempotent law means that if you have X or X, that is equal to X, right? X and X, that's also, X. So, because it's the same variable, right? Whatever it, because the variable X can have two values, right? True or false, right? So if X is true, then X or X, right? True or true is still true, false or false is still false. So that's what that means, right? So, emulator law is like if you have or, and then something true, right? If something is always true, or something else, then this whole expression is always true. Because if one is true, like if you have A or B, right? If one of those is always true, then this whole thing is true. Right? Is that right? You need to just logically understand those laws, then it's easy to remember. Right? If it's the AND operator, then if anything is false, right? Because for A and B to be true, then both have to be true, right? So if any one of them is always false, then it's always false. So that means in here it's written as X and 1, right? If X and 1 is X, but the one above, X and false, is always false.
Yeah.
Right? So you just need to logically, understand these laws. Then it's not too hard to remember. And then the complement law means that if you have X or not X, right? A or not A, then this whole expression is always true, right? Because A could be true or false, then the other one is always the opposite, right? So if you have X and not X, it's always false, right? They cannot be both true, right? Right? Logically, if you think about it, if you have something that is true, then the not that thing, right, is always false. So they cannot be true at the same time. So these are all, logics, right? Logic. And if X is true, then not X is false, right? If X is false, then not X is true, right? They cannot be both true. That's why, these laws are just, a summarization of these logic operations so that, when you look at, trying to simplify up, expressions, it's easy, right? It becomes kind of obvious when you look at them, right? And I think the latter two, the double negation is easy to understand, right? If something is false, false is true, right? And you false again is again false. So x, whatever x is, you double negate that. It becomes that thing itself, right? So, and the De Morgan laws and the distributive laws, these are the ones that that you can commonly or very often encounter in those simplification problems. Right? If you look at trying to simplify something, you can try to manipulate that expression into some format that you can use either distributive law or the De Morgan's law to modify the expression and then eventually simplify them. Because once you can break these parentheses and stuff like that, and then you put 2 and 2 together, and then you can eliminate them using other laws. The last problem is graph theory. Graph theory, again, is probably new to you guys, right? Because you don't learn these things at school. But to summarize them, these are the things you need to remember, really. Right? What is a graph? A graph is a set of vertices, nodes, and edges. Right? Then you have complete graph. What is a complete graph? It's
graph that is graph that can complete graph.
It's a graph that is completely connected. Completely
So
connected,
every single
meaning that
vertice
every single one of the nodes are connected to each other, right? That's correct. But the thing is, completeness is basically something that just says, well, we're all directly connected. Then it's a complete graph. Traversability, we'll come to that, right? Then you have the these are concepts, right? Path. What is a path? This path is a way for you to reach from one node to another, right? There's a path exists. A path exists between the two nodes. That's called a path. So you can get from one to the other, right? That's and then connected graph, meaning that the graph is connected, meaning that you don't have loose parts, right? So you can always reach from one point to any other point in this graph. That means it's connected, right? Right? Because if you have, the definition of graph just says nodes and edges, right?
Is a complete graph a complete graph?
No, because what you can have is something like try to do a here drawing, right? So if you look at this, right, these are connected graphs, right? But if I have two of these things in a graph, then these two parts are not connected, right? If I make this one graph, right, then these two parts are not connected, right? Or we can say, if you have A, B, and C, right? If we have 3 here, logically, this is still a graph, right? ABC, right? It just has 0 edges. And even if I add edges to it, right, this, for example, if I connect A and B, this is a graph, right? But this is not a connected graph, right? And to be a connected graph, I would have to connect the C into the graph, right? Now it's a connected graph. But is this complete graph?
No.
No, right? Because you don't have a direct connection from A to C. So if I do this now, yeah. Now it becomes complete, right? So any node in this graph is directly connected to the other graph, to the other node, to other nodes, right? And if I add another node in this graph, I didn't mean to do that. So right, if I add a new node into this graph, again, if you want that to be complete, right, you'd have to add a few more edges, right? You have to add AD, BD, CD, right? Right, for this graph to, again, be a complete graph. But to be connected, I just need to add one edge, right, for it to be connected graph. So that's those concepts. What else do we have? And cycle, right? Cycle, as you can see, basically, in this graph, ABCD, you only have one cycle, right? ABC, right? Because it's not directional, so that's the only. Well, I suppose in this one you can have two, ABCA and ACBA, right? So, if that order matters, right? But in this one, for example, then this A, B, C, D, E, and to count all the cycles, you would have to, work on that a little bit. The trick for that is to, go to the next node. When you start from A, for example, in this one, you go to the next node by the order, right? Alphabetical order, so that, it's easier to not repeat things. So you go here and say A, D, B, C, D, A, right? I don't know if that, yeah, that would work. But A, D, B, E, A, right? A, D, C, B, E, A, right? And things like that. And so you can remember where you have been, and you don't repeat stuff. What else do we have? Traveling salesman's problem.
Oh yeah.
Remember that?
No. Go find the shortest route to get
to all the nodes, right? Because for a traveling salesperson, the target or the goal is to go to all the places, right? Without having to go back and forth. And let the route be the shortest because you don't really want to walk a whole lot, right? Or travel a whole lot unnecessarily. So the problem is really, to summarize it, it is to find the shortest path through all the nodes. Okay, so you travel the minimum, the least number of paths, the edges, right? And then the traversability problem is somewhat opposite to the traveling salesman's problem, right? In terms of one is to get to all the nodes, right? The traversability problem is to go through all the edges.
One time.
Exactly, one time only. So the rule for that is you have 0 or 2 vertices have odd degrees. Right? Odd degree meaning odd number of connections out of that node. Right? That's the key to traversability. You just need to remember that. Thank you very much for for coming to learn with me over the summer. I don't know if your parents are here.
Thank you for teaching us.
All right, and next semester I have submitted